Hey there, this is video U527. We are practicing with our Z-scores and we're working on finding percents. So let's get at it. The selling price of a 1985 Ford Rangers are normally distributed with a mean of $3,200 and a standard deviation of 350. Okay, I'm not reading anymore. I'm going to draw my chart. Because I know pretty much every question requires a lovely chart like this if there's mean and standard deviations. All right, so 3,200 plus 350 and minus 350. Okay, sorry guys, I'm just gonna do this. Because my rating's too big. $3,550, 3,900. And I'll go up and do subtract. 2,850, 2,500. Okay. This is dollars. Price at truck. Enter frequency 0.15, 0.35, 13.5. Oops. Brain got ahead of me. I was thinking 68 for the next two. 34, 34, 15.5, 0.35, 0.1. All right. Now, what percent of the trucks are going to sell for less than $3,000? So, well, there's 28.5 and there's 3,200. So I'm going to guess, and really, it is just an estimate or guess, that right there is 3,000. Okay. Now, I like to estimate before I do the question. So I'm looking at coloring in all of this. Well, it's going to be all of this section, which is 0.15, plus all of that section, plus all of that section, and then part of this one. So if I go 0.15 plus 2.35 plus 13.5, it's going to give me 16%. And I'm just going to write more than. So that'll help me if I screw up and I do something wrong with my calculations if I get some crazy number. Because usually what happens when you make a mistake like that is instead of getting 16, you're going to get like 92% or something. It's going to be like really off and you'll catch it. But that's not good enough as an estimate. That's about. So what's the rule? Come on, you know. Exactly. Z-score. Not to mention that it says Z-score practice right up there. I'm going to put it down here. X minus X bar over sigma. So this is less than 3,000. Z is equal to, now the number I'm worried about is 3,000 minus X bar, that's my mean or mu, right? Remember, X bar is for sample, they both mean mean. They both represent mean. This is for sample, not everybody, this is for everybody. But the point is you need to remember that X bar and mu are basically the same thing. 3,200 over sigma, and sigma was standard deviation was 350. That's going to be minus 200 over 350. Now watch your sign, because signs really do matter. Well, they always do, but they're super important on this one. So 200 divided by 350, 0.5, whoopsies, 57. Standard deviations, and it was negative. Always 2 decimal places because we're going to be using our charts. And I just put the SD to remind me that's what I actually calculated. Now, let's see if that looks right. So here is, remember your mu or standard deviation, that's basically the 0 point. And it says my line is minus 5.7. Yepers, that looks good because this is actually the -1 standard deviation, -2 standard deviations, -3 standard deviations. You knew that. So that seems reasonable. But the question didn't ask for how many standard deviations. It asked for the percent. So you got to get out your handy dandy table. You should have a copy of this. Forgive me, negative 0. I'm just writing it on a piece of scrap paper because I keep forgetting. We need to be on the negative side. There's 2 sides to the table. This one over here on the right, it's got all the positive numbers. This has got all my negatives. So I need 0.5, and remember we split between the 2 decimals. So I'm going to go down this column and find 0.5. Oops, can't see it. Did I go far? Still didn't make it. There we go. Okay. And then I need 7. So negative 0.5. And then I go up here and find the 7 and go down 28.43. Okay. Get the book out of the way. So area, A for area under the curve, I don't know, that's what I always use, is equal to 0.2843. I'm just going to write from table. So if somebody is looking at this as a written answer key, they'll know where this number suddenly appeared from. All right, and that is as a decimal, so we multiply by 100. So area is equal to 28.43%. And when we estimated a while ago, we said it should be at least, no, we said more than 16%. And indeed, that works out to 28%. So that's saying that this colored section over here is 28.43% of my data. That makes sense. We said for sure it was more than 16, and we actually could have said definitely less than 50. So that is what we do. I would challenge you now, turn off the video and do the question of more than 3750. Did you? Cool. All right, so 3750 is my pen. All right, there's 3550, there's 3900, so I'm gonna eyeball. And I'm gonna say that's 3750. So we are looking for that area there. I'm going to do an estimate again. Okay. You don't have to do this part because I know for some students it drives them completely bonkers. But if it's going to be more than that, we know it's going to be all of this little area. So again, we're going to get more than 0.15. And it's going to be all of this, 2.35. That's going to be part of that one, but I don't know how much, so I'm not going to bother including it. But I know it's going to be somewhere around there, which is about 2.5%. So in that area, cool. But in that area is not good enough. You know that. So set score. X minus X bar. Sorry, just checking our textbook to see if they actually give you the formula somewhere. Over sigma. Z is equal to, now what's the number we care about? The number we care about is 3750 minus 3200 over 350 over standard deviation. So Z, oh, I was going to do that in my head, but I don't think my head number's right. Minus 3200, sure. No. Yep, not even close. So divide that by 350. Oh, you can't see anything. Here, let me got 1.57. Standard deviations. Now, before we go further, sorry, I got all twisted there on you. Let's see if that's reasonable. So it's positive, which means my number is higher than my mean. Good. So from there to there is one standard deviation. And from there to there is some more. So that's reasonable. So we're golden. Now we need to pull out the table. Gotta write that down. All right, so I need 1.57. So we get our book out. And we gotta make sure that we're using the positive side, right? The other one was negative 0.57, so this is 1.57 positive. So 1.5, so we're gonna split it there. So I need to find the 1.5 column. Okay, so I look down my row, there's my 1.5, and then I go across to get to my 0.7, and I get 0.9418. I can check this one more time. 1.5 is there. 7 is coming down there. 9418. Okay. So 9418 is. Always times 100 to convert it into percent. Okay. What just happened? Don't worry, we didn't screw up. Because remember, the graph, and I'll show you, it's right there in the picture, and the directions. To determine the percent of the data with a z-score equal to or less than a specific value. So they, no matter what, are always giving you the part on the left of the line. We want that stuff that's to the right. So what we just did, now I'll show you. I'll show you an amazing, pretty amazing picture. Make sure you can see it. plus 1.57 standard deviations. This is telling me that this area back here is 94.18%. But that's not what the question wants. The question wants that part. Well, if this is 94%, exactly, 100% minus 98, whoopsies, 94.18. .82%. And there is our final answer, because 5% would make, whoops. This being 5% makes sense, because from here to here is 2.5% and some more, but it's definitely less than 16 because it doesn't go all the way to here. There, now I've got, so you can see both parts. That's why I really, really like these pictures, because if you draw the sketch and color in the part that you're worried about, you shouldn't make a mistake when you get a crazy answer like 94.18. It shouldn't scare you. It should just be, oh yeah, right. It's always giving me the stuff to the left. If I want more than stuff on the right, I just have to subtract from 100. And you know what, guys? There's a really good tip. Anytime it's wanting more than a certain value, you are always going to be subtracting to get it. Remember that. Have a great day.